Hey guys, last lesson of Unit 6 and then we are done with Unit 6. Sweet. Okay, so let's start off. This lesson is kind of two big things, so it'll be two videos. This first one that we're going to talk about is trapezoidal approximations. Now, last lesson in 6.7, we used rectangles, but you probably noticed that rectangles aren't very good at approximating curves because rectangles are lines and curves don't fit them very well. So right here, using trapezoids to approximate areas is more accurate than using rectangles. Kind of like this graph you can see here. Those trapezoids fit this graph, this curve, a lot better. So this is the last approximation we're going to talk about, is using trapezoids. Now, normally, your trapezoid looks like this, and here's the area. That's just the formula for area of a trapezoid. 1/2 times the height times the bottom base plus the top base. However, when we're doing these graphs, we're never going to draw these trapezoids on their side. Like you can see in this example, the trapezoids always go up and down. So that's why we're gonna change it to this right here, and we're going to use this equation. 1/2 width of your square, of your rectangle, of your block, height 1 plus height 2. So let's go through that with our first example. So we have 5 trapezoids here. Now you may say, Mrs. Johnson, 2 of these are not trapezoids. This one's a triangle and this one's a rectangle. Well, look at this note here. The area formula for a trapezoid also works for a triangle or a rectangle. So let me show you this. So let's say I have a triangle right here. This is my width. This is my H1, and this is my H2. So if I look at doing this formula, 1/2 times width times H1 plus H2. Well, do you see this H1? That's 0 because that's flat. So just like we have right here, this side, this H is going to be 0. So this is really 1/2 times width times H2 because that goes to 0. And there you go, 1/2 width times height. There's your area for a triangle. Now let's try a rectangle just so we can see it. Here's our width. Here's our H1. Here's our H2. So 1/2 times width times H1 plus H2. Well, H1 and H2 are the same thing. They're the same height because it's a rectangle. So it's really H1 plus H1, which is really 2 H1s. And now you'll see this 2 and this 1/2 are canceling each other. So we get width times height. There's your area of a rectangle. So this trapezoid equation works with trapezoids, works with triangles, and works with rectangles. So we can still use it even though not all of these look exactly like trapezoid shapes. So let's go through. I will do the first one, and then I'm going to have you pause the video to do the other 4 and add them all together. So we've got 1/2 times our width. So it looks like our width there is 2 times our height, our first height, which is going to be 0, plus our second height, which is up here at 4. And that is, those 2's become a 1, that's a 4. Okay, I want you to pause the video, find the area of these other 4 trapezoids, 2, 3, 4, and 5, and then add them all together. Come back and check to see how you did. Check what you got with what I got. And remember, for free response, you don't need to simplify. If it was multiple choice, you would definitely want to simplify. But that's what you should have gotten. If you got something different, you can pause the video now and go back to figure out where you went wrong. Let's do our next trapezoidal approximation. Okay. Use these trapezoids with 4 equal subdivisions to approximate the area shown. So all of our widths are 10. Our heights are found in the table that mine got separated from, but you should have yours right next to each other. So the y value at 10 was 1.8, just looking at that table in your notes. The y value at 20 is 2. The y value at 30 is 2.5. Y value at 40 was 3.5, and the y value at 50 is 2.2. So what I want you to do, pause the video, find the area of all 4 of these trapezoids, and then add them together to get your final answer. Okay, check what you got with what I got. This is what I got, and once again, you can continue simplifying that should for multiple choice. For a free response, you really could even just leave your answer like it is up here. You don't even need to simplify to that step. Okay, that is it for trapezoidal approximations. In the second video of today's lesson, we're going to talk about the limit definition of an integral.